So where we left off, we started to look at these group level results. I'm going to take a slight detour into PPI analysis as well. Come on. Get out of there. Okay. All right. I know there were a couple issues with a couple attendees about getting the second level running. Some of them it seems a little idiosyncratic, so I can't give a definite diagnosis. But what I would say is, if you don't have the external hard drive data right now would be a good time to get it. And on your own time outside of this, that functional connectivity module that I wrote follows very closely what we're doing today. So if you repeat those steps, if you kind of just wipe the site clean, try downloading everything again, doing it, see if it works, and if it doesn't, that might require writing to Alfonso. So I'm going to punt on that one. All right, so moving on to group level analysis, actually making inferences about how to do these. So we've talked about functional connectivity, what it is, Conn's approach to pre-processing and denoising, and your choices for using these different first level covariates. When we talk about group analysis, when I show you that montage of the individual slices, that's all the group analysis is doing. So it converts these correlation values to a z-statistic at each voxel. Then within each voxel, because they're all normalized to the same space, it says, is that value across all the subjects consistently positive, consistently negative? Is it a mixture? Does it kind of average out to zero? What happens exactly? It's really the same thing as doing a t-test at that point. When we start to do the practical section of this, I'll point out where exactly you can find those values for the ROIs. If you're more comfortable, analyzing them in a separate software package, you can definitely do that. Everything is stored and organized very neatly in CONN. Before I go on to talking about group level analysis, this seemed to be the right place to put this in. Just to back up and talk about these PPI analyses. I talked about them briefly yesterday, these psychophysiological interactions. This is an example from just a paper I found. If you have something like two conditions and you're looking at the functional coupling or, say, correlation between two regions, in this case it did amygdala and IFG during some kind of, say, cognitive control task during an emotional stimuli presentation, does the correlation between those two tend to change based on what condition you're in? Okay, so if you, say, estimate the correlation between the two in condition A, this is between, they gave people either one drug or placebo for two conditions, and they examined whether the correlation changed between that. So that's the basic recap of what a PPI is. Now, I also alluded to something called generalized PPIs yesterday. Everything we talked about so far is a so-called traditional PPI, where you have a psychological regressor, that's the effective task, a physiological regressor, that's the time course from the seed region, and then when you multiply the two, you get this interaction term that you examine at each particular voxel. So remember, it's not directly a one-to-one correlation that we're looking for. We are instead looking for a interaction between them. So as, say, the task variable, if we code them for, say, -1 is task A and +1 is task B, so you can see task B goes up, and then it goes down to task A, up and down. If we multiply that with the physiological regressor, you'll notice that the negative sign makes this seed region flip to positive if it's negative here, and to negative if it's positive up there. Okay? And then you match that interaction regressor at each individual's time series. See where it loads. With a GPPI, you just simply extend this to however many regressors that you have. So if I have 3 tasks, or three conditions, there'd be, so A, B, and C, there would be a PPI for every possible combination of those 3. It's simply examining the entire experimental space and accounting for all of it. So even if you're only interested in, say, the interaction between A and B, you still need to model the interaction for C with A, C with B, and that will actually improve the overall model fit. When we get to GPPIs, the practical section a little bit later, this is basically what it will look like. And this is where BIDS format really shines, because if all the timing files are in BIDS format, you simply click a button to import it, and it will automatically assign all the onsets to the right conditions. Again, I've tried to break it, I've tried to fool it. As long as the basic terminology is consistent across the subject, so sub-01, sub-02, and the inat and func directories, it will correctly match everything up. When I first was using this a year and a half ago, they didn't have this function yet. You had to manually import, enter everything. Or you had to have text files in a very kind of weird format. But these days, it's much, much simpler. So we're going to be moving on to these task-based analyses within the CONN toolbox, where you're modeling the effective task. I'll explain more about what that, what these different bars mean when we do that practical. But in any case, we already covered the first level results. Again, you can't do an inferential analysis on that, but you'll need to do it for every subject in order to do the second level analysis. Now, if you want to do any kind of, say, group comparison, enter any second level covariates, you need to go back to the setup tab in order to do that. It's a little weird, takes some time to get used to, but that's how you're going to do it. So let's see here. Yes. When we enabled the second level analyses, you may have noticed also that there are different group level analyses that you can, say, choose from. The 2 basic ones, the 2 ones that we're just doing for this workshop today, because we don't have time for all of them, are seed to voxel and ROI to ROI. Right? So seed to voxel, you take an ROI, you correlate that with every voxel in the brain. ROI, you take every parcellation in your atlas or network, and you correlate each of those with each other. And you can create those connectome matrices we alluded to earlier. It creates group level maps just like you would see with traditional task-based analyses. But you also have options for things like if you want to do pre-post designs, compare groups, continuous measures, and so on. These last few, say voxel-voxel, ICA networks, dynamic ICA. This is a relatively new technique. Dynamic ICA is using a sliding time window across the time series to see how the connectivity changes over time, basically. So in other words, if somebody seems to have, say, a greater, say, rate of change in their correlation, that'll be reflected in this dynamic ICA window. And ICA networks are what you would traditionally see in a task-based analysis, where you extract different components from the network. But in this case, we're just going to be focusing on these first 2. I haven't worked as much with these, so I can't speak too much about how you'd use that for an actual research question. But these first 2 are very straightforward for most questions I'm assuming people are interested in this particular context. All right. So what you'll see at the second level, going back to this first level tab, there is an option to change this from functional connectivity to GPPI. So we will be coming back to this in a little bit. There are other options we'll explore here, but again, not necessarily all of them. If you want to only restrict your analysis to a subset of, say, networks or ROIs. You don't want to look at everything, every possible combination. You can simply deselect most of these. By default, they're all selected. But if you want to, you can remove some of them. Again, up to you. Even if you include all of them, you do have an option even at the second level to still restrict it if you want to. But it's really up to you, up to your research question. If you include everything, as you'll see, you even with 6 subjects, you will get a significant effect. It's almost like doing an F-test, for example. If you've done an F-test for task-based data, you'll know that generally this is testing is there any activation anywhere for any condition. Not terribly interesting, but it's still a good sanity check to make sure that there actually is something going on. If the F-test showed nothing, then you probably there's something wrong that needs to be fixed. Okay. The data that you do see on the second level tab, recall earlier you had the option of, you do smooth. Smoothing is a default part of the pre-processing stream. But when we actually run the connectivity analyses, it's extracting that from the unsmoothed data. We talked about that before. We don't want to be introducing some spurious correlations, right? That's in contrast to task-based. But you'll notice that at the second level, these effects are actually, they're blurred a little bit. Partly for aesthetic reasons, partly after you've already done the connectivity analysis. If you then average together, say, some nearby z scores that have been transformed, you can, in that case, actually say boost your signal a little bit. I don't know how to directly control that, but that's why this thing looks the way it does. It's been normalized to a template. There's been some interpolation going on, and it's also blurred a little bit as well. Similar to the that cluster defining threshold we talked about earlier, it's kind of hard to see, but there is a p-corrected value down here. That's similar to that cluster defining threshold we're talking about before. In this panel, that's only for visualization purposes. That won't affect the actual inference of your results. Later on, when we click on Results Explorer, that's how you'll actually generate the statistics that you'll look at. So don't use this particular graph to make any kind of inference at that point. You can still use it to get a kind of a sense of the data. You can use different plots if you want to see what the variation is like between the subjects. But don't use that in itself for the for your inference. Okay. You'll also see this tab right here. This is from the second level tab, but it imports everything from your setup tab. So again, this is the thing that takes the most getting used to with the GUI. But every effect that you have in the setup tab, you can test for a main effect of that. If you select multiple conditions, this makes sense more in the context of, say, a PPI. You can test for contrast between the different conditions, between groups, and also second level analyses. You'll also be given a list of all the possible seeds and sources, all the networks that you also imported from the setup tab. So the upshot is anything that you change in setup is reflected immediately in the second level tab. That does not mean you have to rerun all the intermediate steps, however. So once you pre-process everything, get to the second level tab, and you go, actually, there was a group comparison I wanted to do. Don't worry, all you need to do is make a couple of changes to setup, and you'll be fine. So people have made this mistake before where they then think, oh crap, I got to rerun everything. That's not true. However, if you do want to denoise a particular regressor that you forgot before, you would need to rerun everything. So make sure that that is all set up before you do any of these group inferences. So let's see here. So these are the covariates. We'll cover this in a second. I'm not going to spend too much time on that. Let's see here. Second level covariates is another thing at the setup tab that you'll be able to account for. So it outputs these all these regressors from each subject. It'll take an average for them for each subject, and then you have the option of inputting those into the second level model, right? So in other words, you know what sources of variance you account for. It gives you every possible combination, and you're probably not going to be using most of these. The ones that you will use are probably ones you're going to be defining manually. Okay, so if I had, say, an age covariate, if I had something like a mean FD score I wanted to use to classify the subjects, I could do that. If I had a pre-post design, this is also where I could put that in there. Let's see, I believe that I included a sample covariate in the hard drive, but there's also a download link to download this sample covariate that we'll play around with. It's a very simple format, so no matter if you're looking at age, what are some other ones? Help me out here. What are some other second level covariates? Gender, height, I don't know, man. It's just whatever you have. You can input that as a covariate. Okay, so at this point, let's see here. Yeah, I think at this point we're just going to break out and demo the second level. Okay, the people who were having the issues before with getting the second level set up, has that been resolved yet? Any further problems? Okay. Is that? Oh, no, there are no problems. Okay. Right. Okay. Very good. So if we go back to this, make sure that your mat file is loaded, and then click on results second level. We're going to be looking into these analyses a little bit more. First, we're going to look at, we're going to give you a couple templates for things like group comparisons, second level covariates, and then we'll move on to looking at the actual results in the Results Explorer. So again, this is the preview pane. This is uncorrected, so if you want to, you can change it if you want. I mean, it's not going to be terribly interesting, but mostly just to make sure that the second level results is in the ROI that you think it should be. We talked about plotting, whoops. You can plot subjects if you want to. This is kind of a biased ROI analysis, only for descriptive purposes, just to check it out. You wouldn't want to run any actual inferences from that, right? But if you want to, there's no harm in it as long as you don't publish it. But if you click on any of these voxels, you can plot the overall effect and also the variation around it. It's not for inferential purposes, however. This is not a standard error. Okay, I'll leave the other ones to you to explore as you want. But if we go back to our setup tab, for example, let's say, and down here, covariate second level is what we need to change if we want to then see the effect later on. So you'll notice that we have, some potential covariates. These are things that have been averaged across all the different subjects, right? So mean motion, maybe you want to include that, maybe not. It's up to you. It has different measures from all the different ROIs it segmented. We're not going to cover all those. But for right now, let's say that we, again, this is not a valid analysis. Okay, I just randomly picked the first 6 subjects in this data set. Are they different? I don't know. But let's say that the first 3 were group A, second 3 were group B. Again, this is a template for you to use in your own data. If the first 3 were group A, second 3 were group B, we're going to need to create 2 new covariates, dummy coding which one is in group A, which one is in group B. So this plus sign allows you to add a new covariate. It's going to be blank when you first open it up. In group name, you can call it whatever you want. I'm going to call this group A. And this values is going to be a vector that's automatically filled in for however many subjects there are. So if there's 6 subjects, it's going to be 6 zeros. In this case, it's going to be 1, 1, 1. Common mistake, somebody wants to do, say, between groups analysis. They'll do 1, 1, 1, negative 1, negative 1, negative 1. Statistically, that's not actually valid. We need to create another separate regressor, group B, and dummy code that for, say, 1, 1, 1. If you press enter, you'll see it's almost like a stick function. There's ones for the ones that were labeled with a 1 and zeros for the ones that were labeled with a 0. Okay. Good so far? If we then click on results, you will see those particular values updated right here. Again, 3 in each group. Is there going to be a difference? No. But if you click on each one individually, it'll show you the different group effects. So, say main effect for group A, main effect for group B. It's not going to be meaningful just off the bat, just so you know. But technically, we have everything set up to do a group level analysis or a between groups analysis. If I highlight both of them, hold down the left mouse button, select both of them, you'll see that this other, these fields are now filled in automatically. It gives you an any effects f-test, but if I want to do something like difference between group A, group B, where is group A greater than group B, I would simply select that. And notice that this contrast fills into 1, negative 1. You may notice this hasn't really changed necessarily over here. You can still click around and see where group A seems to be higher than group B, for example. It's not going to show you a direct contrast map, though. To look at that, we're going to be looking at the Results Explorer, which I'll get to in just a second after I go through the rest of the permutations. So I can look at that. You can also look at group B greater than group A, any kind of combination you want. Just effective group A, effective group B, however you want to do that. Clear? So pretty simple. Between groups is a very simple analysis to set up. If, on the other hand, I have some kind of covariate I want to look at, age is a good example. What I would like you all to do, if you have the schedule page uploaded here, where do I have that? If we don't have it, I mean, it's just a simple thing to fill in. Oh, custom atlas, and okay, this is from later on, but you'll use it right here. It's under day 2, 11:30 a.m. to 12 p.m. A custom atlas and covariate files can be found here. Click on that to download, unzip it, and oh, I already had it. Whoops. No. I already have this thing, but ROI covariates. And then using Finder, simply move it over to your whichever directory contains all of your subjects. Yeah, okay. So I'm going to move this over here. Okay, now if I wanted to, I could do this manually. Let's say I have age for each subject. I could click here, I could enter covariate name of age, and if I have other different ages like 21, 24, 6, 19, 3, something like that, you need to make sure that there's one value for every subject or it's going to throw an error. You'll get something like this, okay? And if you're comfortable doing that, that's fine, you can leave it like that. I'm going to remove that and show you how to import the same thing using CONN toolbox. So under covariate tools, you have a few different options. One is import new covariates from data file. Select that, and then within that ROI covariate folder you downloaded, there's covariates and a file called age.txt. So very useful if you have a lot of subjects and maybe a lot of covariates, because you can select multiple ones if you want to. When I import that, these are just some random numbers I filled in. Again, this is not really representative of a real analysis we're doing right here, but more for your own benefit. So what do these actually look like? These covariates are pretty easy to make if you want to just take a look at it. The very first one is going to be a header. So in this case, age, and then a list of all the different covariates for one per subject. Now the key point here is you need to make sure that this list of covariates matches up with how you set up all of your individual files. So this should match with subject 1, subject 2, subject 3, however many that you have. Okay, once you have that, a good idea, something I like to do is mean center the data. You can do this manually, or you can do it automatically through CONN by holding control and selecting both your covariate and the all subjects variable. If you click on orthogonalize, oops, where is that? Oh, sorry, don't select all subjects. Only select this covariate right here. Then when you select orthogonalize, select all subjects. It'll mean center it. Notice that mean centering has no effect of if you're looking at, say, the correlation of age with the effect on correlation, for example. It's not going to have any effect on the significance level for that. It will affect slightly if you're looking at the main effective group or main effect of a contrast between them. Okay, so we have the imported, go to results, and then you have something else to look at. This probably isn't going to correlate with much at all. Notice if I only select that, it's not going to show me anything. It'll give me a warning. What it wants me to do is also supply a constant term. So basically, what is this actually being correlated with? So I'll need to select this and then that as well by holding down Control. Now for each of these things that we've set up here, in just a second, we're going to be using Results Explorer to see the effect of each of those. What you see over there is still the main effect of each group individually. For some reason, it doesn't show the direct contrast or the correlation between them. But this is how you would select something and then look at it in the results. So I blocked off 10 to 10:45 for just overviewing how to import these different things. Any questions so far before we go on to viewing the results? Good with that? We're going to view the results and then PPI analysis. Yeah?
I couldn't get it to import, but is that okay for now if I just enter?
If you enter it, that's fine too. Okay. What error did it give you?
It said that something about string.
With the number of subjects?
Yeah. I can look at that later.
Okay, but you can enter it and it works fine. Okay. Okay. Tell you what, give me a quick 5 minutes. I just need to rest my voice a little bit, get some more water. We'll come back, look at the results, and if there are any problems up until this point, let me know. We're doing very, very well. This is going very smoothly. So, okay, great. Meet back 10:52.